All right, hello and welcome. In this video, we're going to be talking about completing the square, which relates to a new form of our quadratic equations that we haven't necessarily talked about yet, that is called vertex form. So to understand how this works, the first thing I'm going to do is draw you a little graph and just sort of illustrate what it is that we're going to be talking about. So here we have just a random parabola that I drew. Um, so the new terms that we need to know for today. The first is the term vertex, which refers to the point that's in the exact middle of our parabola. So this guy right here. There's always going to be an imaginary line that kind of splits our parabola in half. And that imaginary line is our axis of symmetry. So the vertex point always hits the parabola at the axis of symmetry. And so far, we've seen equations of parabolas in standard form, which is ax plus bx plus c. We've seen our equations in factored form, which we use to help us find the x-intercepts or the roots of solutions. And so now that we understand what the vertex is, we're going to look at equations in vertex form, which is y equals a times x minus h squared plus k. So let's look at what these letters mean so we understand what this formula is telling us. So the first thing I want you to notice is that the letter A here is the same. And so that represents the same number in both forms. So if my x squared has a number in front of it in standard form, that same number is going to be in front of the parentheses when we convert it into vertex form. The other thing that I want to point out is that the letters H and K represent the vertex point or the coordinates of the vertex. So what we're going to look at next is basically how to take an equation that's in standard form and convert it into vertex form so that we can figure out where the vertex point is on that parabola. All right, so let's say that I had the standard form equation y equals x squared plus 10x minus 7. To convert this into vertex form, I notice that I want one side of, or one piece of the equation to factor to something with a perfect square. So in other words, I want to see an x minus something or an x plus something squared. And so of course, we know that that exponent means that we basically want something to factor with the same number twice. So the first thing that I'm going to do is take anything that does not have an x and I'm going to switch it to the other side. So I need to take that 7 and add it to both sides. Then what I'm going to do is do the process of completing the square. And so what that means is I'm going to add a number to both sides of my equation so that the side with the x factors to a perfect square. So to figure out what number I need, I'm going to take whatever's on the right side, which would be that x squared plus 10x. I'm basically just going to take the 10x and split it in half. And so if I do that, I can factor an x from the top row, which means I would need an x here, which means I need a plus 5 here and a plus 5 here. And so when I multiply my 5's together, I get 25. So if I take that 25 and add it to both sides, when I simplify the expression, I'll have something that factors on the side with the x's. So the first thing I'm going to do, or rather the next thing I'm going to do, is take the right side of the equation and factor it using the box that I wrote out already. So if I have x squared plus 10x plus 25, I know the factored form of that is x plus 5 squared. And then on the left-hand side, I can just combine my like terms. So I should take 25 plus 7 to get 32. And then to finalize my vertex form, I'll just take that 32 and move it back to the other side. So I'll see y equals x plus 5 squared minus 32. So I copied down the original version of vertex form that we had written down so that we can kind of compare it to what we ended up with here so that we can figure out our A, our H, and our K. So I noticed that in my blue equation, there's nothing in front of the parentheses. And I know that when I'm talking about coefficients and equations, if I don't see anything in front of a number, then that's implied that there's a 1 right there. So for this particular equation, A equals 1. I know that my H is whatever's in the parentheses. But I noticed that in the original equation, right, in the purple equation, the H has a minus sign. In the blue equation, the 5 has a plus sign. So since those signs are flipped, my H is going to be negative 5. And then when I look at the K, I notice something similar, right? The K has a plus sign in front of it, but the 32 has a minus sign in front of it. So my value of K is actually a negative 32. So if I start with a vertex or a standard form of x squared plus 10x minus 7, I convert that into the vertex form, which is x plus 5 squared minus 32, which tells me my vertex coordinates are negative 5 and negative 32. So let's look at one more example really quickly. So let's say I had my standard form equation of y equals 2x squared minus 8x plus 5. And let's say I wanted to convert this into vertex form. So the first thing that I would do, once again, is move the 5 to the other side by subtracting. Then, before I can complete the square, I also want to get rid of whatever number is in front of x squared. So I'm going to divide everything by 2. So I'll say I have y minus 5 over 2 equal to x squared minus 4x. And so here is where I'm going to fill in my missing value. So once again, I copy down my x squared. I take the negative 4x and split it in half to get 2 and 2. And then when I factor my equation, I notice negative 2 and negative 2 multiplies to positive 4. So that's what goes into my missing value. From here, I'm going to factor the right-hand side of the equation. So the x squared minus 4x plus 4 becomes x minus 2 squared. And then I'm going to take what I have on the left and move it back to the other side. So the plus 4 over here becomes a minus 4 over here. Since I divided by 2 to make the fraction, I'm going to multiply by 2 to move that over. And then finally, to move the minus 5 to the other side, I'll do plus 5 instead. So what I will end up with is y equals 2 x minus 2 squared minus 3. So my vertex point is at positive 2 and negative 3. That's all I have for this one. I will see you guys next time.